And here's the crazy part. Every single day, Elasticsearch processes billions of search queries for companies you use every day. Billions.
Billions? Really? That's staggering. I mean, I know it's used a lot, but that scale is hard to even imagine. What happens if even a tiny percentage of those fail?
Exactly. That's why we're talking about Elasticsearch today. Think about it. What happens when search on Airbnb goes down? People can't book places. Hosts lose money. Airbnb loses credibility. It's a business-critical system. The cost of failure is enormous. Same with GitHub. Developers can't find code. Productivity grinds to a halt, and suddenly everyone's grumpy.
Okay, that makes sense. So we're not just talking about a nice-to-have feature here. We're talking about the backbone of some of the biggest platforms out there. But why Elasticsearch specifically? There are other search technologies, right? What makes it so well suited for this kind of scale?
That's the million-dollar question, and the answer lies in its architecture. Elasticsearch is built for distributed search and analytics. Think of it as a massive, highly organized library, but instead of books, it stores data, and instead of librarians, it has powerful algorithms optimized for speed. The core concepts are indexing, querying, and scaling, which we'll dive into.
Okay, indexing. Let's start there. I understand the basic idea. You need to organize data to find it efficiently. But how does Elasticsearch do it at this scale? What's the magic sauce?
The magic is in the inverted index. Imagine a regular book index at the back. It maps keywords to page numbers. Elasticsearch does the same, but for every field in your data. So if you're searching for cozy cabin near lake, Elasticsearch already knows which documents contain those terms and where they're located. This is incredibly fast.
But wait, doesn't that mean it needs to pre-process all the data and create these indexes before you can even search? What about real-time data? Like, if someone posts a new listing on Airbnb, how quickly does it become searchable?
Excellent point. Elasticsearch uses near real-time indexing. It doesn't wait for a full batch process. New data is added to a temporary buffer and periodically flushed to disk. The cool part is that even while the data is in the buffer, it's still searchable. This happens in a matter of seconds, making it feel instantaneous to the user. Think about Netflix. They're constantly adding new shows, and you can search for them almost immediately. That's near real-time indexing at work.
Okay, that's impressive. But creating the index is only half the battle, right? What about the query inside? How does Elasticsearch handle complex queries with filters, facets, and all that jazz?
This is where Elasticsearch really shines. It uses a powerful query DSL, domain-specific language, based on JSON. This allows you to build incredibly complex queries with Boolean logic, fuzzy matching, range filters, and more. For example, on GitHub, you might search for open source machine learning library Python license MIT stars greater than 1,000. Elasticsearch can parse that query, efficiently filter the results, and rank them based on relevance.
So it's not just about finding the documents that contain the keywords, it's about ranking them in the right order. How does it determine relevance?
Relevance is determined by a scoring algorithm, typically BM25. It considers factors like term frequency, how often the term appears in the document, inverse document frequency, how rare the term is across all documents, and field length. The more relevant a document is, the higher it appears in the search results. Think about Google search. They are masters of relevance ranking. Elasticsearch gives you the tools to achieve similar results.
But what about typos? I mean, users make mistakes all the time. Does Elasticsearch just return zero results if I misspell something?
Not at all. Elasticsearch supports fuzzy matching and auto-completion. Fuzzy matching allows you to find documents even if the search term contains typos. Auto-completion suggests relevant search terms as you type, guiding the user to the correct query. This is crucial for user experience, especially on platforms like Wikipedia, where people might not know the exact spelling of a topic.
Okay, so we've covered indexing and querying. Now let's talk about scaling. How does Elasticsearch handle the billions of queries you mentioned earlier? One server obviously can't do it.
You're absolutely right. Elasticsearch is designed to be distributed across multiple nodes in a cluster. Data is sharded, meaning it's split into smaller chunks and distributed across different nodes. Each shard is also replicated for redundancy and high availability.
So if one node goes down, the other nodes can still serve the data, but how does Elasticsearch know which shard contains the data I'm looking for?
That's where the routing algorithm comes in. When you send a search request to the cluster, it's routed to the appropriate node based on the shard key. The node then searches its local shards and returns the results. The results from all the nodes are then aggregated and returned to the user.
But wait, doesn't that mean that every search request has to go through multiple nodes? Doesn't that add latency?
It does, but Elasticsearch optimizes this process through caching and parallelization. The results of frequently accessed queries are cached, so they can be served quickly. Also, the search requests are executed in parallel across all the nodes, minimizing the overall latency. Cloudflare uses similar techniques to handle massive traffic spikes and deliver content quickly. So it's a combination of sharding, replication, caching, and parallelization that allows Elasticsearch to scale to handle billions of queries. That's a lot to think about. And here's where it gets interesting. Most engineers focus on optimizing the query itself, making it faster, more efficient. But the real bottleneck often lies in the data model. If your data is poorly structured, even the most optimized query will struggle. What do you mean by poorly structured? Can you give me an example? Sure. Imagine you're storing user data in a single massive document. Every time a user makes a change, you have to re-index the entire document. This is incredibly inefficient. A better approach is to break the data into smaller, more manageable documents. For example, you could store user profile data, activity data, and preferences data in separate documents. So it's about denormalizing the data and optimizing it for search rather than for relational integrity. But doesn't that introduce data duplication and potential inconsistencies? It does, and that's the trade-off you have to make. You need to carefully consider your use case and decide whether the performance gains outweigh the potential risks of data inconsistencies. In many cases, especially with search-heavy applications, the performance benefits are well worth it. Uber, for example, likely denormalizes a ton of data to power their real-time ride search and matching algorithms. They prioritize speed and accuracy over strict data normalization. Okay, that makes sense. So what should a software engineer do differently after listening to this? What are the practical takeaways? First, understand your data. Don't just throw it into Elasticsearch and hope for the best. Spend time analyzing your data and designing a data model that's optimized for search. Think about how users will be querying the data and structure it accordingly. This is like designing the blueprint for a skyscraper. If the foundation is weak, the whole thing will crumble. And second? Second, monitor your queries. Elasticsearch provides powerful tools for monitoring query performance. Use these tools to identify slow queries and optimize them. Look for common patterns and try to identify the root cause of the performance issues. This is like having a doctor check your pulse. It gives you valuable insights into the health of your system. And finally? Finally, experiment with different settings. Elasticsearch has a ton of configuration options. Don't be afraid to experiment with different settings to see what works best for your use case. Try different analyzers, different scoring algorithms, different caching strategies. This is like a chef tweaking a recipe. Small changes can make a big difference. So, understand your data, monitor your queries, and experiment with different settings. That's a great set of actionable takeaways. Exactly. Elasticsearch is a powerful tool, but it's not a magic bullet. You need to understand how it works and use it effectively to get the best results. It's not just about the technology, it's about the architecture. And if you don't architect your data well, even the most powerful search engine will just be spinning its wheels.